Welcome to Calculus 1, folks, and I'm so excited for you to get started in this class because in my opinion, calculus is the second coolest subject of all. Calculus is incredibly useful, more useful in my opinion than pre-calculus could ever be, except for a few things maybe in trigonometry. I would say that in this class, calculus and the tools of calculus are going to have three main applications. The first main application is that we're going to be able to take something which is curved and which is complicated and break it down into something linear, which is easy enough that many of you probably encountered it in your beginning algebra courses. The idea is this. Suppose you have some curved thing. The equation to this might be complicated. It might be some evil sum of sine functions, such as you might have studied in pre-calculus or something like that. Or maybe this is some awful complicated polynomial like t to the 5th power plus 2t squared minus t to the 7th. Who knows? Working with these kinds of polynomials or trig equations is so much harder than working with something that's linear, like 2 times t plus 3. Linear equations were so much easier to graph and to solve and evaluate than any other equation that we encountered in our work. Calculus gives us a way to take something that's curved and break it down into tiny linear segments. Instead of dealing with this complicated green curve, we might approximate that curve by, in some sense, a necklace of tiny line segments. That way, if you're working with a portion of the graph, you can get away with just working with the linear segment that approximates the graph at that location. Calculus is the tool that tells us which line segments are good approximations to the curve at any given point. These approximating line segments are called tangent line segments. Calculus also allows us to take the entire equation of a function and replace it with a linear equation, which is a good approximation. One of the most famous examples is that sine of t can be replaced just by the input t when t is small. So if you're dealing with sine of something and the angle is pretty small, just ditch the sine and deal with the input by itself. You won't lose that much data if you get rid of the sine. So t can be used as a linear approximation to sine of t, and calculus allows us to find linear approximations to all kinds of other functions. One of the other main applications of calculus is that it allows you to tell how fast a function is changing. Suppose, for example, that I had a function which represented the height of an object over time. For example, maybe f of t had the equation negative 5t squared plus 10t plus 3. This would be pretty reasonable as an expression of the height of a launched object, launched from a height of 3, increasing for some time and then falling back down to the ground. Now, using the techniques of algebra, you could answer all kinds of questions about this launched object. You could say things like, what was the initial height? You could figure out at what time the object fell to the ground. Using algebra, you can even figure out the object's maximum height which corresponds to the vertex of this parabola. But in calculus, you unlock the ability to tell not only where the object is at any given moment, and not only when it reaches certain locations, but also how fast the object is traveling at any given time. Calculus allows you to determine rates of change. Things like velocities, things like acceleration. How fast is the function's value changing? How fast is the object moving? That's something that calculus can be used to answer. Calculus can also be used in optimization. Optimization is just the fancy word for getting the best out of any situation. Now, in an abstract sense, getting the best out of any situation might look like finding the highest point on a complicated curve. But in real-world applications, the quote-unquote highest point on a curve might end up representing something like your maximum income. Finding the highest point on the curve might represent something like maximizing your academic performance or athletic performance. Calculus can also find the lowest point on a graph. In real life, might represent something like minimizing your expenses. Might represent something like minimize the amount of time you spend on a project. Or minimizing the cost of materials for a project. Using calculus, you can do all of these things. Now, those are just the applications that we will be looking at in Calculus 1. But the basic tools and techniques that we'll be learning in this class will give you some foundational skills for all the other calculus courses that come after it, and will give you the ability to learn all the applications in those courses. In Calculus 2, for example, you can calculate averages of complicated functions, calculate areas and volumes. You can get into the more interesting physics calculations of quantities like hydrostatic pressure. You can calculate cumulative totals, distance traveled by an object. All of that is available to you in Calc 2. You also unlock the ability to access all the applications of Calculus 3. This is where you start to analyze functions that can be represented by complex wave patterns like sound waves. You can approximate functions not just with lines, but with polynomials when it's convenient. You can analyze trajectories of moving objects and find lengths of wires. And in Calculus 4, get into even more complicated volumes and surface areas, more complicated totals, more complicated optimization. You can analyze fluid flow through surfaces or heat transfer, and you can look at the movement of a fluid. And once you've taken all the calculus classes, you can get into differential equations, which is where things really get good. You can look at circuits, you can look at ecosystems, population growth, the spread of a virus, radioactive decay series, beams that are being bent under weights. All of that becomes available to you, and the foundation of that, the beginning of all of those applications, is right here in Calculus 1. To outline the general sketch of what this course is going to look like, we're going to start by talking about a mathematical object called a limit. And a limit is going to allow us to calculate something called a derivative, and this is where the magic happens. Derivatives are what this course is all about, and this is the tool that you use to do all the applications that I listed in the first part of the video. When we introduced the derivative, we're going to introduce some rules and shortcuts for how to calculate it. And once we're pretty comfortable calculating the derivative, we're going to go ahead and use the derivative to do all the applications mentioned above. And that's the outline of the course. Now, some of you looking at the title may be wondering, okay, if calculus can do all that and that's the second coolest subject, what's the first coolest subject? And of course, the first coolest subject is